Okay, so we'll start in Eagle, and for me, I've already exported this, so when I go over onto the right and click on Fusion Sync, it gives me these options of just simply pushing to Fusion. If you haven't done this yet, it'll ask you which folder within your Fusion folders you want to save it in. So just select that and then send it over. And then there's one other step, which is go to File, Export, and the DXF. Take off the vector font and the fill areas, and OK. So those are the two things that we need to export. Alright, so we get it open in Fusion, and you'll see the board is more or less populated already. This is pretty helpful if you want to design the rest of the, like the enclosure or other parts that you want to include with your design. For us, we just want to hide all of those components. Really, the only reason that we actually export the board itself is this gives us the holes. And the reason we exported DXF is it gives us the circuit. You see the circuit outlined here, but it's just an image, a rasterized image, so it's not going to allow you to pick out the paths themselves. That's what the DXF gives us. All right, so we're going to put the DXF on top. So we go to Insert DXF, select our board, and select our DXF file, and then that'll take a little bit. And we want to take off all the different layers from Eagle that we don't need. In my case, I only need 1 and 17. And okay, this will take a minute. All right, so now we have the circuit itself on top of our board, which you can see here. So what we want is the outline going around each of the different traces. And that's the path that we're actually going to cut out from our circuit board. So one thing you can do is just click on that path somewhere and extrude it. I'm going to extrude it negative because this is sitting on top of the board. Extrude it negative 0.1 inches. And that'll look like that. Alright, so then we just go through all the other components. This is a little bit tedious, so I'll speed it up. One thing to notice, I'll stop here. So there's some bug, I don't know if it's in Eagle or in Fusion, that on occasion you'll get these, I don't know, there's areas that just don't work out right. So there's two ways you can deal with that. One is in the sketch workspace. If you just draw a line over those areas, that seems to sort of fix the bug. I don't know why, but that seems to fix it. If it's just a small one like this, there's another way to fix that. The problem with drawing a line over it is, in a lot of cases, it takes a long time actually. It takes maybe a couple minutes for every line that you draw. So there's a faster way, if you can deal with it, is just to continue as I'm doing here and extrude it as normal. So it all looks pretty good except for that one little spot, so we'll fix that. So I'll just draw a cylinder actually. And pull it through. Doesn't have to be exact. And just cut it. Alright, so that's close enough. That looks pretty good to me. Okay, so let's bring our board back. So the way we're going to do this is, because we only need the holes from the board that was exported directly is we'll just create another box that is the same dimensions as our board, and then do a combine and intersection to get the holes on our new circuit board. So now I'll do the combine, intersection between our new box and the original board. And okay. Alright. So if we hide our board, and we can see, so now we're looking at our board plus all of our extruded paths. You can just check it out, make sure it all looks alright. Okay, so now we'll do a combine, select our board, and then select all our different paths, which is our circuit. Do a cut, and keep tools for now just in case we need them again. And click OK. Okay, and then we can just hide all those, so select them all and hit V. Alright, so now we should see more or less the circuit board that we want to cut out with CAM. One thing I'll do is add some fillets to the corners, just to make it look fancy. And let's go 2 millimeters. And let's do 3. Looks good. Okay, now I missed storing this part of it. So to create the setup stock, so I just created the stock to match the thickness of my board and to match the height and width of my actual the board that I'll be cutting it out of. And then you can put the origin wherever you'd like. You can put it in the center as I'm showing here. Actually, what I did is I put it in the bottom left on the top corner. I mean the bottom left top for the front surface. What I'm doing here is check what the distances are, the thickness of our the surround for your traces, and in my case it's 0.008 inches. So I'm using a V-shaped bit with a 60-degree included angle, and this is a little bit of a trick. So using the V-bit with the engraving bit with Fusion is not so convenient. So what I do is I lie to Fusion and I tell them I'm using a square bit that's of a particular diameter. And so what I'm going to do is, since the whole width of the cutout that I want to do is 0.008 inches, I'll say that my V-bit is actually a square bit that is like 0.006 inches. So I'll go make this tool. I'll call it my FOW V-bit. With a flat end mill, just call it 2 flutes. And go 0.006 inches. And then just make the rest of it sort of look reasonable. Doesn't really matter. And I'll call this tool 40. That's well away from all my real tools. Okay, that'll work. So now I'm going to go to 2D Pocket. I'll select that tool I just made. 40. I didn't set the speed, so I'll set that. That should work. Alright, and then we're going to select our paths. So I'll just grab one pocket for now, just to make sure that everything is working. I'll come back and get the rest later. I set the heights lower just because, don't have to do that. Turn off stock to leave, and I'll go with plunge instead of helix. Okay, let's see if that worked. Alright, so that looks like it worked pretty well. It'll just go and make a little loop through my pocket. So now I'm going to check the warnings, so it looks fine. Then I'll add some more here. I'll speed this up for you. Okay, looking good. So now I'll duplicate that so I don't have to redo everything, and just go and pick out different pockets this time. So I'll grab this guy. This will take a second. Okay, so this will happen sometimes. So you see it's made the entire thing blue highlighted. That's not what it's supposed to look like. And I think that's related to the problem that I mentioned earlier in the CAD process, where I have these little glitches. It was in the top right of my board. When these happen, it's quite annoying, but if you see, when you click on the bottom of a path of a pocket and it turns all blue like this, it's not going to work. So what you got to do is cancel that and go back and select the edges. So select the outside edge first and then the inside edge, and that effectively does the same thing. Duplicate that and get these other ones. So sometimes you see it works fine, sometimes it doesn't. Okay, so let's simulate this and see what it looks like. Alright, those are looking good. Okay, now something's not right here. So you see it's actually the bottom of the path, the tool path, is on the top surface of the board. It's not digging in at all. So that was a mistake. So when I chose that CAD, or the cam for the pocket, what I accidentally did was I chose the top corner. You have to choose the bottom corner. So select the bottom outside corner first, and then the inside corners, and then it should work. Okay, let's simulate again, and that's looking better. Okay, so then I will just select my drills as normal. Select all my little holes. And these bottom 3 holes are actually a little different, so I'll grab my different tool. Alright, and then I would do the cutout. So in here I selected some settings that are a little bit too aggressive. So this is with just an 1/8 inch square bit. I would recommend going with a cutting feed rate of 10 and a little bit less of a step down than I selected here. So I did 0.04. I actually in my final version I did 0.035, I believe, and so that worked a little bit better. This is a little bit aggressive. Okay, so the way I'm going to hold this is another sort of not so simple thing to do, is decide how you're going to hold your board. So I have this piece of 3D printed material that was just scrap from something I made a long time ago. So I use that as my sacrificial board, and I use double-sided tape, some 3M, pretty strong stuff, to hold that to my vise. So I tape that backing board down to the vise, and then I'm going to apply some of the same tape to the back of my board. Okay, so the first thing I'm going to do is turn on the drill with M3 S1000, turn on 1000 RPM, you can see the bottom. And then I'm going to jog it over until it just touches the circuit board, and then I'm going to zero that out on the Z-axis. And then I'm going to go over to the bottom left corner. So again, this ties back to what you call the origin in your cam. In my case, I called the bottom left corner the origin, and so that's where I'm going to zero it out. If you decided to do like the top center, then you would go to that top center and zero it out there. But so in my case, I'll go to the bottom left corner, and then 0 DRO for the X, 0 DRO for the Y, and also the A table. So to keep it at that 90 degree that it's at right now. Okay, and one other thing is make sure that your tool offset, the Z offset for your tool, is set at 0. Very important, otherwise it will not be anywhere near correct. Okay, start cutting. The tools I'm using have the collar, and so that keeps the consistent depth. So once you've already set the Z depth on the first one, then you don't have to set the Z again. But this bit that I'm using to cut out, it doesn't have the collar, so I had to redo the Z offset and set that back to 0 for the offset and the DRO. So that's one reason it's nice to have the bits with, if you have all bits with collars, then it's a lot more convenient for this process. Okay, and the finished product.